Okay, quiz 11, question 5. I think a lot of people miss this question simply due to a terminology issue, because this is another unit where we have a lot of synonyms to describe one thing. So the question stated, following injury, an uninjured axon sprouts to innervate a synaptic site that was lost due to a damaged neuron. What is this called? The answer was reactive synaptogenesis. I'm going to move the camera to a diagram that I made to better explain this. Okay, here we go. So here is my diagram. All right, so over here we have a damaged neuron due to brain injury or what have you, stroke. And you can see now that this pathway has been interrupted. You've lost conductivity. This neighboring pathway, which is undamaged, is going to sprout to restore the conductivity. Because these two pathways are right beside each other, they probably have the same function. So if this uninjured axon, the key word there being uninjured, sprouts, we can call it collateral sprouting or reactive synaptogenesis. So this uninjured axon is reacting to what's going on beside it, and it's growing a sprout, which is what synaptogenesis means. Genesis means growth. Collateral sprouting, same thing. Okay, synonyms. If this damaged neuron decides to regrow itself to restore conductivity, then we would call it regenerative synaptogenesis or neural regeneration. Okay, neural regeneration and regenerative synaptogenesis are also synonyms. And that would be when the injured or damaged neuron regrows itself. So we've got neuroplasticity to damaged neurons, and neuroplasticity can occur in undamaged or uninjured neurons. Okay, and both of those processes are what we would call a direct mechanism of recovery. So regenerative synaptogenesis, if this one regrows itself, or collateral sprouting, they're both indirect mechanisms of neuroplasticity. The other item that was on the test or the quiz was unmasking. Similarly, you could have a damaged pathway here, and before the injury you have this neighboring pathway which doesn't sustain any injury but is silent. A silent pathway. In our nervous system we have a tremendous amount of redundancy, and this redundancy is very important and helpful when we have an injury, because in the event of an injury over here, this silent pathway can immediately wake up to restore function, and that's what we call unmasking, which is another direct mechanism. And then the last item on the quiz was deinnervation supersensitivity, and that is what happens in Parkinson's disease. And we're talking about growth postsynaptically. So if this postsynaptic neuron regrows, or not regrows, but increases the rate of growth of receptors to capture more dopamine, that would be called deinnervation supersensitivity, meaning the postsynaptic neuron is becoming really sensitive to dopamine. Dopamine is the neurotransmitter in Parkinson's disease that disappears over time. So once the system realizes that there's less dopamine in the cleft, it's going to grow more receptors to capture every last little bit of dopamine that it can. Again, that's called deinnervation supersensitivity. And that's it.